Hello IB. I wanted to spend a bit of time going through your IAs before you actually submit your final copy and final work to us. We gave you out this checklist before and thought this would be a good way to listen to the video, have your IA open and check things off as you go through so that you can present your best work. So I'm going to run through each of the criteria and show each criterion and show you what that means and what things you should be checking. So let's start with your communication. This is how well you're communicating all your maths and your story to in your work. The first important part here is your aim, rationale and conclusion. You should at the beginning have a clear aim. So suggestion there is you could put it in italics, have a separate paragraph, but make sure it's very clear, not vague, so that I'm going to investigate such and such and explain clearly. A rationale needs to be there, why you're doing it, and then your conclusion should answer your aim. So each time we talk about these things, stop the video, check it all, fix up your IA as we go through it. Make sure your conclusion has answered your aim. If you have other things in your work that are not to do with your aim, then either change your aim or think carefully, are they relevant to what you're aiming to do? So if your aim's not clear, then that's a bit hard to write your conclusion. So that's your aim. All working must be shown. If you jump steps and just come out with a number or not show where it comes from, you are not communicating clearly. Does it flow? Can I just read it? Can your teacher read it easily and understand what you're doing? Have numbers suddenly appeared from nowhere and not explain why? Your peers understand it. Anything irrelevant I've just mentioned. Don't repeat yourself. State your aim clearly. Don't then change it or reword it, speak it again. Just watch for repetition. The length of it, you just keep an eye on that. If you're up to about 18 or 19 pages, then you really need to think you should start what you should be cutting out. Next one is on the referencing. Anything that you've brought in from somewhere else needs to be referenced properly. So you need in-text referencing, maybe using your Harvard or whichever method you're using. But if you have a diagram, there should be a little number next to it and saying whereabouts that is. Don't have things in your footnotes like definitions that we need to read. So, but any quotations all need to be carefully and properly annotated and referenced properly to your bibliography. So that's your mark out of 4 for your mathematical communication. The next one here is your presentation. So this is saying how well you're presenting your maths. So you've got the booklet that talks about the descriptors for each of these. You should have a range of mathematical presentation, and that could be equations, tables, graphs, diagrams, flowcharts, whatever different ways you can present the maths in your investigation. Make sure all your graphs and tables have headings, and you could also number them table 1, figure 1, etc., because that's a really good way of being able to refer back to them. So what I'd like to do is just quickly show you for moderating. So basically your IAs are handed in. We, your teachers, will mark them. We will do cross marking between each of us so that you come up with a final mark. Then we upload your marks to the IBO. Then they request for our size 8 samples will be sent off. A moderator will then get those samples. So this is an example of what, as a moderator, the work I'm seeing. So you can't see whose they are or where they're from. So what I wanted to do is show you just a couple of works that have come up and what we're looking at when we're moderating it. So in this one here, we've got references, and for this student, this is an example of a good graph that can be easily seen. This is an example of not a good graph. So they're going to be scanned in, and we will scan in colour so that any colour that you have is seen. But for this, It's good having all this information, but we can't even possibly read the values here. Even when we enlarge it, all right, it's still very hard to see. So if you're having a table of values that you're getting from, like in this case, the students got it from GeoGebra, then make sure it's bigger. Make sure your graphs and table, any graphs should be a third to half a page size. All your axes need labelling. See, you can't read that. You don't even know what that label is. Don't even know this one. Even if you have to put your own text box on top to say what it is. So graphing, those graphs and everything are very important. So this student here has done a great job with their graph, where it's very clear what the labels are on the axes and what the values are. They've just taken it out of Excel, which can work well, but if you're using other, like graphical analysis, the numbers tend to be quite small, so be careful with that. They've included the equation, they've shown that in this case. Don't have those shown if you're not using them. Excel tends to do R squared. If you're not using R squared, then don't get that showing. Anything that you show, you need to refer to. Here, the notation, that's written properly. If it wasn't written correctly, if it had like that little mountain top, the little carrot top for the indice, you should rewrite that. So watch how your graphs are looking. So do they have labels, and are they large enough to read? Don't use the incorrect calculator notation like the star or asterisk for multiplying. Have you got a range of tools to express your ideas? Those I mentioned. Have you explained all terms? Don't have abbreviations like, I don't know, NFL, the National Football League, all right, in the States. Don't assume that your markers know everything about everything. So any abbreviations you should expand or explain. Terminology should be explained. Another one I just wanted to mention, which where this student has got, where's some maths happening? Let's see if we've got some maths happening in this one. All right, okay. See how this student's worked out and come up with various equations. I've seen in some work where they actually put like a number over here in a bracket. So this might be equation 1, and this might be equation 2. Where are we? Just down a bit. Oh, up. Now that's equation 2 or something. So sometimes it's helpful to have these equations numbered if you've got a lot of algebra that you're working through. Note that they've got all really good notation here. And significant figures, that's the other key thing in criterion B, is how many significant figures are relevant for your work. And in this case, they've kept a lot here in the middle of the working, but when they come down to the final equation, we've got 1, 2, 3, 4, 5 significant figures. Here we've got 5. Is it okay to have 5 significant figures? You need to think about it and discuss that and be consistent in any final equations. Here, is this an exact value or has it been rounded? If you're doing any rounded, then your equal signs need to be an approximate equal sign. So please be really careful. That will get pinged. Most times, that's one of the most common ones that we're spotting in criterion B, is a lack of consideration of significant figures and not using an approximately equal sign where needed. So that's mathematical presentation. Your personal engagement, you certainly need to have some link to why you're investigating it at the beginning, but from then on, it's so much about how you've made this your individual investigation or your exploration. Your examples, your way of proving things, your data, any independent and creative thought. If you're doing something that's common in a textbook or lots of physicsy sort of proof, like modelling, the trig function or whatever, if it looks like it's just come from a textbook, that's not a lot of personal engagement. It's how you make this different and unique. And so to get 4, to get that abundant and outstanding personal engagement is very hard, because people might get their own data, but then they just do a stock standard regression on it, which is, well, there's nothing very creative about that unless you go one step further in terms of dealing with the maths or dealing with the data in a different way. So personal engagement is how you're dealing with the maths and presenting your own independent and creative thought about it. Next one, reflection. Remember, we mentioned that whenever you come up with any result or graph or table, reflect on it. Talk about what it shows you. So if you come up with an equation for modelling it, what does that equation do? What does it tell you? All right. What are any limitations? All right. What you've done, will that always work? What are the strengths and weaknesses? So the 2 key areas you're reflecting on are the actual maths, the numbers that you're coming up with, and then the second one is your mathematical processes. Was the process you used a valid process? Why did you choose those points to model it with? Why did you choose that equation? Is it right to choose a linear equation? Should have used a quadratic? What does a quadratic, does that make sense within the domain, beyond the domain? So that detail, to be critical, which is your top level, you need to make sure you've commented all the way through your work. What are the implications of your result? This could mean that sort of reflective comments. Ask questions. Are there different perspectives? So you've really got to go in detail. If all you have done is explain your results and go, this is what my result was, then you're on level 1 for reflection. So remember, every time, all through your work, comment, stop and comment, look at it, think about it, interpret it within context, and just wonder about what does that really mean? Is it valid? Is it not? The last one here is your maths. So make sure at this point, hopefully it's a bit late now, but hopefully you've got something that is commensurate with the course, that you're using some SL level maths and that you've clearly demonstrated understanding. Have you shown all the steps of your working? So if you're going to work out an average, you're going to show one average calculation. If you're working out an R value, you're going to show a calculation of an R value to show understanding. You're going to talk about what values can R be. If you're going to use a regression equation, like a linear equation, then you're going to talk about what does that equation tell you? What's the slope tell you? What's the y-intercept tell you? If you're doing a regression, remember your R value is a linear regression. It's correlating to a straight line. Is that valid if your data is not in a straight line? You need to think about that. Check for mistakes. You can get someone else to check your maths there. Make sure all your steps are showing to show clear understanding, and then interpret your results at the end. What else with the maths? Your R values I've talked about. Yes, what's it really mean? Let me think. Maths. Yeah, so when you're choosing your equations, if you're going to choose a quadratic, explain why you're choosing a quadratic. Also show that if you're doing those regression and you come up with an R squared value, that's not the same as an R value. An R value is a linear correlation. R squared is what the computers will come up with, that coefficient of determination. So make sure you refer to it correctly. If you just use technology to come up with your solutions and don't show how the technology is coming up with that or where it's coming from, then that will limit you probably to a 3 or 4 in this criterion. So really you've got to explain what equations and why, and model it yourself as well as using your calculator to do a whole range of them. Don't repeat calculations. It's enough to do one lot of each calculation and have that as evidence of your understanding. So the key point here is to demonstrate understanding. So it's got to be seen by your marker and not just assume that we know that you understand it. Can you print in colour if you've got colour in your graphs? Don't forget you're going to be putting it through Turnitin and number your pages, because that's very helpful in the IAs as a marker. There was one case where it had been scanned, but only every second page was scanned, and it was easy to spot because I could see that pages went from 1, 3, 5, apart from the fact that it just didn't make sense, it didn't flow. So that's what you should be aiming at in getting your work finished and handed in. So hopefully that's of help. If you want some, we can't look at your IAs again because you've had your one feedback session, but certainly happy to come in if you've got particular questions. So all the best as you finalise your IAs, and looking forward to reading them all. Thanks for listening. Bye for now.